Greetings and welcome to the video. Today, we are going to explore a fascinating topic in astrophysics: stars eating their planets and spitting them back out again. It might sound like a gruesome and tragic event, but as we will discover, it doesn't always have to end in doom. In fact, a team of astrophysicists have used computer simulations to reveal that planets can not only survive engulfment by their parent star, but they can also drive its future evolution. So, how exactly can a planet survive in the intense atmosphere of a star? Let's find out together in this video. Planetary systems are formed when a cloud of gas and dust collapses under its own gravity. As the cloud gets smaller and denser, it begins to spin and flatten into a disc-shaped structure called a protoplanetary disk. Within this disk, small grains of dust begin to collide and stick together, eventually forming larger and larger bodies called planetesimals. These planetesimals can then collide and merge to form planets. However, not all planets in a planetary system will survive. Due to the chaotic nature of orbital dynamics, many planets end up being consumed by their parent star. Some planets might collide with each other, while others might be ejected from the system altogether. The ones that are sent hurtling into the star are typically the ones that are on very chaotic orbits, and their fate is sealed by the powerful gravity of the star. This phenomenon of planetary engulfment is not uncommon throughout the universe, and it can happen at any point in the life of a star. Towards the end of a star's life, when it becomes a red giant, its gravitational influence can become much stronger, and this can cause some of the larger planets in its system to be engulfed by the star. Despite this destructive event, researchers have discovered some surprising things about the fate of these planets. Let's explore more in the next segment of THE video. Random interactions among newly forming planets and the protoplanetary disk can have a significant impact on the dynamics of a planetary system. Some of these interactions can send planets on chaotic trajectories that can either drive them out of the system or send them hurtling into the star. For example, if a planet is on an orbit that takes it too close to another planet, the gravitational pull from the other planet could alter its trajectory, sending it on a collision course with the star. Similarly, if a planet's orbit is too close to the star, the intense gravitational pull from the star could cause the planet to spiral inward, eventually leading to its engulfment. These chaotic interactions are often difficult to predict, and they can happen at any point in the life of a planetary system. This means that even if a planet has been in a stable orbit for millions of years, it could be sent careening into the star at any moment due to a chance encounter with another planet. However, despite the destructive nature of planetary engulfment, researchers have discovered some fascinating consequences of this phenomenon. Let's explore these in the next segment of the video. Planetary engulfment can also occur when a star runs out of fuel and begins to expand into a red giant. During this phase, the star swells to many times its original size, which can disrupt the orbits of any planets in its vicinity. If a planet is on an orbit that takes it too close to the star, the intense gravitational pull from the red giant can cause the planet to be stripped of its outer layers and ultimately be swallowed by the star's atmosphere. This process of engulfment can have some profound consequences for the star itself. For example, if a planet is large enough, it can survive its journey into the star and continue to orbit within its atmosphere for thousands of years. As the planet orbits, it can fling off material from the star, thinning out the outer edges of the atmosphere. In other cases, the exchange of orbital energy between the planet and the star can actually accelerate the evolution of the star. This is because the planet's gravity can cause the star to spin more quickly, which in turn can cause it to burn through its fuel more rapidly. This can ultimately lead to the star's demise, freeing the planet from its deadly embrace. Despite the apparent finality of planetary engulfment, researchers are continuing to explore its effects on stellar evolution. By using computer simulations to study these processes, they hope to uncover new insights into the formation and evolution of planetary systems throughout the universe. Although the idea of planets surviving engulfment may seem far-fetched, astronomers have actually observed several odd systems throughout the galaxy that suggest it is a relatively common occurrence. For example, there are white dwarf systems that are orbited very closely by a giant planet, too close for that planet to have formed naturally. This suggests that the planet may have been engulfed by the white dwarf at some point in the past. Similarly, there are stars with a surprising amount of heavier metals in their atmospheres, which is a sign that a rocky object has plunged into it. This is known as metal pollution, and it is a strong indication that a planet has been consumed by the star. In some cases, astronomers have even been able to identify the specific elements that were present in the planet's atmosphere before it was engulfed. Finally, there are stars that are rotating far too quickly for their age, and in some cases, this can be explained by the infall of a planet. As the planet falls towards the star, its gravity can cause the star to spin faster and faster, which can ultimately lead to the star's demise. All of these systems suggest that planetary engulfment is a relatively common occurrence in the universe, and that it may play a significant role in shaping the evolution of stars and their planetary systems. By studying these systems in greater detail, researchers hope to learn more about the complex interactions between planets and their parent stars, and to gain new insights into the formation and evolution of planetary systems throughout the cosmos. While the idea of planets surviving engulfment by their parent star may seem unlikely, a team of astrophysicists have used computer simulations to show that it is not only possible, but it may even drive the future evolution of the star. In their simulations, the team studied planets of various masses, as well as brown dwarfs, to see how they might fare in the intense atmosphere of a star. Interestingly, the simulations showed that in some cases, planets can survive engulfment for thousands of years, swirling around the center of the star within its atmosphere. This orbital action can fling off material from the star, thinning out the outer edges of the atmosphere. In other cases, the exchange of orbital energy drives up the temperature of the stellar atmosphere, making it appear much brighter than it normally would. However, the team found that in order for a planet to survive engulfment, it must be relatively large, at least the mass of Jupiter. Small planets like the Earth cannot survive in those conditions. But if the planet is big enough, and depending on the precise evolution, the planet can survive its passage through the star and actually accelerate the evolution of the star so that it ends its life quickly, freeing the planet from its deadly embrace. These simulations have important implications for our understanding of planetary systems and their evolution. By showing that planets can survive engulfment and even influence the evolution of their parent stars, the research opens up new avenues for exploration into the complex interactions between planets and their stars, and may ultimately help us to better understand the formation and evolution of planetary systems throughout the universe. One interesting finding from the simulations is that the exchange of orbital energy between the planet and the star can have a significant impact on the star's behavior. In some cases, the planet's passage through the star's atmosphere can cause it to brighten considerably, as the exchange of energy drives up the temperature of the atmosphere. This effect can be seen in observations of white dwarf stars, which are the remnants of stars like our Sun that have exhausted their nuclear fuel and collapsed. Astronomers have found many white dwarf stars that appear to be much brighter than they should be, based on their size and temperature. One possible explanation for this is that a planet or other object fell into the star, causing it to heat up and brighten. The simulations conducted by the astrophysicists support this idea, and suggest that the exchange of energy between the planet and the star can have a profound impact on the star's evolution. This means that planets that are engulfed by their stars are not just passive victims of their environment, they can actually shape the evolution of their parent stars in important ways. While the simulations suggest that planets can survive being engulfed by their parent stars, not all planets are created equal when it comes to their chances of survival. The survival of the planet depends on its size, with larger planets having a greater chance of survival than smaller ones. For example, the simulations show that planets with a mass similar to Jupiter can survive in the intense environment of a star, while smaller planets like Earth would be unable to survive for long. This is because the intense heat and pressure in the star's atmosphere would quickly cause a small planet to disintegrate. Interestingly, the simulations also show that the survival of the planet depends on the precise evolution of the star after the planet is engulfed. In some cases, the planet's presence can actually accelerate the evolution of the star, causing it to end its life more quickly and freeing the planet from its deadly embrace. Overall, the simulations suggest that the phenomenon of planets being engulfed by their parent stars is more common and more complex than previously thought. By studying the behavior of planets in these extreme environments, astrophysicists can gain a better understanding of how planetary systems form and evolve over time. We've learned today that planetary engulfment by stars is a common phenomenon throughout the universe. Astrophysicists have used computer simulations to study how planets can survive being swallowed up by their parent stars. They found that not only can planets survive engulfment, but they can also drive the future evolution of the star. We've discussed how random interactions during the formation of planetary systems and the red giant phase of a star can lead to planetary engulfment. We've also explored various examples of odd systems throughout the galaxy that suggest planets have survived engulfment. According to the simulations, the survival of the planet depends on its size, with larger planets having a greater chance of survival. Small planets like Earth cannot withstand the intense atmosphere of a star. In conclusion, this research indicates that the universe is a much more dynamic and complex place than we previously thought. We encourage you to share your thoughts and questions about the topic in the comments section below. Thank you for watching, and we hope you found this video informative. Don't forget to subscribe to our channel for more fascinating science content.